In this video we'll look at using a breadboard for our circuits. So the first thing we'll do is go to the search bar and type in breadboard. You'll see there's three types of breadboards. There's a breadboard mini, breadboard small and a regular breadboard. We're going to use the breadboard small. Okay, so what's the purpose of using a breadboard for our circuits? A breadboard isn't necessary for us to create circuits, however it does make it a lot quicker and easier to use. So we use it for prototyping. The pins on the board allow us to quickly add wires and remove wires. So when we're prototyping, we may not have the complete circuit in mind at the beginning and we may have to change things as we go. The breadboard makes this nice and easy for us. To look at the breadboard, it's made up of different rails. So if I hover over one of these pins, you can see these 5 pins are all connected via a rail. That means if I connect a wire to one of the pins, it's connected to all the others. And this makes it easy for us to connect different devices to different wires. On the end here you can see we have rails that go across the other way of the board. And we've got the sign here of positive and negative. The convention is to use these for your positive power and for your ground. So let's connect up a ground to the ground rail and 5 volts to the positive rail. And we'll colour them so we know what we're looking at. So we'll set ground to black and we'll set 5 volt to red. So that means all the pins on this rail now are connected to 5 volt and all the pins on this rail are connected to ground. This makes it a lot easier because if we have more than one component that needs to connect, for instance, to the ground, then we have all these pins that we can connect to. If we wanted to connect something to the 5 volt, we have all these pins. So if we had 2 or more LEDs that needed to connect directly to the 5 volts, we would have had a problem with using only the one pin. But now we have all these options. I'll do one additional thing. I'll connect this rail, negative rail, to the negative rail on the other side. By doing that, we now have all the pins on this side and all the pins on this side for which we can connect to a negative or ground. I'll do the same thing for the positive rails. And now I have the options of connecting on either side. So let's recreate the circuit that we had in the previous video by adding an LED. So I'll bring the LED down here and I'll just show you a mistake sometimes people who are starting out make. If I connect an LED like this, I'm actually connecting both legs to the same rail, which is no good. Of course we need to have electricity running in through one leg and out the other in a circuit. This connects both legs together and short circuits. So I'll turn this around and we'll connect each leg to a different rail. Now the longer leg needs to be connected to a positive, so I'll connect that to the positive rail here by connecting to a pin on the same rail that that leg is connected to. I could have connected to any of these pins because they all connect to this leg. I'll change that to a red cable, and on the rail that has the shorter leg, the ground, I will connect that to a ground rail and I will colour that black. Now just like in our first example, there's a problem here. I'll run the simulation and show that we've now blown the LED. That's because the current is too high. So what we'll do is we'll remove that black cable there and we'll put in a resistor. For the resistor, I'll connect one side to the same railing as the short leg on the LED, and I'll connect the other leg of the resistor to the negative rail, to the ground. And I'll recolour these so that we can clearly identify what we're doing. And then I'll rerun the simulation. And now you can see the LED has lit up. So why have we gone to all the effort of connecting up a breadboard and connecting these rails when we simply could have connected one leg to the 5 volt, the resistor and other leg to the ground? Well, now we have it all set up so we can add multiple components. I could add many more of these LEDs all along here for a full strip, connecting it to the either rail that I wanted to use. Now, as it turns out, in this particular version, I'm not using this wire here to connect this rail because nothing's connected to that rail. So I can remove it. However, I may have other componentry that it may be convenient to use this rail along here, in which case I would reconnect it up. So you can see the 5 volt goes down into this rail, runs along, down into this cable, into this rail, and into the leg of the LED. The circuit continues through the short leg, through the resistor, down into the ground rail, back up along the ground cable, along the second rail, and then back into the ground port.